When you ask a single large language model, an AI trained to generate text based on vast data sets, to structure subjective qualitative data, it immediately runs into a problem known as specialist bias. By prompting the AI to act as an expert in a specific domain, the system inherently inflates the importance and depth of that exact subject. It finds complexity because you told it to look for complexity. A single pass generation cannot correct this flaw. The architectural solution requires building a multi-agent adversarial workflow. This diagram shows a multi-agent system designed to enforce objectivity. The model is split into 5 distinct personas, 4 regional advocates and 1 neutral moderator, all locked into a strict 3-round debate protocol. This institutional structure targets the Lake-Wobegon effect, a statistical flaw where an uncalibrated model categorizes every single data point it evaluates as above average. Rigorous strategic data requires deliberate cross-examination and calibration through system architecture. It cannot be generated in a single prompt. To test this architecture, we use a specific case study, building a master taxonomy of European cuisines to determine the viability of generating individual AI chef personas. The required output is a highly calibrated YAML schema, a human-readable data formatting language used for configuration files, that evaluates each country on culinary depth and English language search demand. We populate the first half of the council with 2 regional experts, a Romance and Mediterranean specialist and a British Isles specialist. The second half of the council consists of a Nordic specialist, alongside an expert covering Germanic and Low Countries. The central control mechanism is the neutral moderator persona. This agent possesses final tie-breaking authority over the entire dataset. By equipping these agents with conflicting academic backgrounds, the system forces the AI to fight over precise definitional boundaries rather than passively hallucinating lists. The target taxonomy evaluates 2 distinct axes: objective complexity, labeled as dish depth, versus market signal, measured as search demand. This scatter plot maps out these variables. Conflating intrinsic depth with market visibility destroys the data. Round 1 begins as an independent research phase. Each agent plots their findings without viewing others' inputs. Operating in isolation, the Germanic agent claims that Germany possesses a very large dish depth, citing the country's 3,200 documented bread varieties as proof. Simultaneously, the British agent stakes an identical claim, labeling the UK's dish depth as very large, based entirely on its 8 distinct regional traditions. Following suit, the Nordic agent grades Denmark, Norway, and Sweden as possessing substantial culinary depth. Looking back at the scatter plot, the flaw is obvious. The isolated models default to placing their own specific domains at the absolute top of the y-axis. Without a comparative framework, an uncalibrated AI model mistakes a sheer volume of raw data for unique categorical depth. Round 2 imposes a new system constraint. The agents are now required to review and actively challenge each other's claims. This prompt parameter immediately breaks the AI's default tendency toward polite agreement, forcing the system into a rigorous adversarial debate. The Nordic agent immediately targets the Germanic agent's depth claims, initiating a debate over the variant problem. The counterargument is precise. Compiling 1,500 local sausage variants does not equate to 1,500 distinctly unique dishes, especially when compared to the cross-category breadth of cuisines in France or Spain. The British agent then launches a retaliatory challenge, attacking the Nordic agent's definition of substantial depth. The British agent argues that individual Nordic countries actually possess significantly smaller culinary canons than Ireland, exposing the Nordic agent's generous self-grading. The adversarial cross-examination exposes the hidden variables and flawed heuristic logic that single-pass AI prompts consistently obscure. In round 3, the moderator persona steps in. Its function is to establish universal calibration breakpoints, but only after observing the fully cross-examined dataset. This chart now features rigid horizontal tier lines animating across the y-axis. The moderator creates locked zones, defining very high strictly as domains containing over 1,000 genuinely distinct dishes. Forced to align with this new system-wide definition, the data points for the UK and Germany immediately drop from very high down into the high tier. Simultaneously, the Nordic countries are pulled down into a standardized medium tier. The moderator then executes its second critical function, breaking heuristic ties that involve complex cultural translation. The council debates identifying the primary culinary authority for French cuisine. One option is Julia Child. The Mediterranean agent argues for cultural purism. It states a primary authority must represent the tradition authentically from within, and points to Jacques Pepin. The moderator resolves the tie pragmatically. It selects Child over Pepin to explicitly prioritize the English language market signal required for the target audience. A robust system design includes an explicit tie-breaking node to systematically resolve the tension between objective purity and practical product utility. This table visualizes the final output, a battle-tested, calibrated strategic matrix stripped of specialist bias. The data isolates invisible cuisine anomalies clearly. Germany, for example, successfully registers a high objective depth paired with a low market search demand. The system also safely houses unresolved disputes. The final matrix records a formal minority opinion from the British agent, arguing that Ireland's initial search demand score was calculated too low. After the council adjourns, late-breaking market data from 2025 and 2026 is injected into the system, showing a measurable surge in U.S. restaurant presence in cookbook sales for Irish cuisine. Looking at the data table, this new empirical evidence triggers a systemic update. Ireland's search demand score dynamically ticks up from a 2 to a 3. By preserving agent descent within the architecture, the system maintains a logical placeholder ready to validate future empirical data. A properly architected multi-agent system absorbs new data without breaking. It gracefully self-updates along pre-established, heavily vetted logical tracks. Extracting high-value, structured qualitative data cannot be achieved by querying a single language model for an answer. The process requires engineering a simulated institution, populated by distinct, actively conflicting personas. It relies on applying strict adversarial constraints that force models to explicitly defend and correct their internal logic. The future of enterprise AI architecture lies not in writing more descriptive prompts, but in designing better deliberative counsels.